everyone. In this video, we will discuss the fundamental principles of counting. The fundamental principle of counting is a technique in counting the number of possible outcomes. There are two methods that you can use in order for you to count all the possible outcomes. We have the listing method and a tree diagram. Now let's use these two methods in our examples. Here's an example. Suppose you choose a sandwich and a drink. How many possible outcomes are there? So in this problem, we will identify the number of options we will have if we have a sandwich and a drink. Given the table, let's count the number of outcomes we could choose: one sandwich and one beverage. So for the sandwich, we have the options egg, hamburger, chicken. And for the beverage, we have iced tea and pineapple. Now we will be using two methods here, the listing and a tree diagram, in order for us to count the number of possible outcomes. But first, let's focus on the listing method. So in the listing method, we will just list all the possible options that we could have: one sandwich and one beverage. So for the first option, we could have egg paired to an iced tea. Second would be egg sandwich again, but this time our beverage will be pineapple juice. For the third one, we could have hamburger and iced tea. For the fourth one, we have hamburger again, but our beverage is pineapple juice. For the fifth one, we have chicken, iced tea. And for the sixth or the last option, we have chicken sandwich and pineapple juice. Now, through listing methods, we will be counting all the possible outcomes that we have here. So that's very obvious. We have 6 options that we could choose: a sandwich and a drink. So that means we have 6 possible outcomes. Now let us move on to the second method, which is a tree diagram, but the same problem. Now for a tree diagram, we will be writing it in this way. In the first column, we have the sandwich, second column, the beverages, and the third column will be the outcome. In the first column, for the sandwiches, we have to list this down. We have the egg sandwich, hamburger, and chicken sandwich. And then for the beverage, take note that we have 2 options. It's either an iced tea or a pineapple juice. So in choosing a sandwich and a beverage, we do this: egg plus iced tea. We have the outcome egg and iced tea. You can choose an egg sandwich and a pineapple juice. The outcome will be egg and pineapple juice. For the second choice of the sandwich, we have hamburger paired to an iced tea and pineapple juice. Let's combine them. Hamburger plus iced tea, we have an outcome hamburger and iced tea, and you can pair hamburger and pineapple juice. And for the third option, for the sandwich, we have the chicken sandwich paired to an iced tea and pineapple juice. Then let's combine them. You can choose chicken and iced tea. That will be our outcome, and you can have chicken and pineapple juice. We have chicken and pineapple juice. Now, if you're going to count the number of outcomes that we have here, we have actually 6 possible outcomes. And that's actually the same with the listing method. So as you can see in the solution, we had plenty of things written in here in order for us to count the number of possible outcomes. But what if there are more than 3 options for the sandwich? What if there are more than 2 options for the beverages? I am pretty sure that we will have a lot of things to enumerate in order for us to count all the possible outcomes. So to avoid that situation of enumerating everything, we could have another way in identifying the total possible outcomes in each problem. So take a look at the options for the sandwich. We could have egg, hamburger, and chicken. That means there are 3 ways that you can choose from sandwich. And then For the beverage, we have iced tea and pineapple juice. That means we have two options for the beverage, and then let's multiply that one. Take note that every time you choose a sandwich, it could be paired to an iced tea and pineapple juice. That's why we multiply them. We have 3 times 2. So again, if we count all the outcomes here, that's actually equal to 6. Therefore, the number of ways or the number of outcomes that we could choose a sandwich and a drink is 6 possible outcomes. That would be the final answer. And that means you can express it in numbers in order for you to get all the possible outcomes. So we have here our solution a while ago that instead of doing listing method and a tree diagram, we multiplied the number of ways we could choose a sandwich and a beverage, and there we got the total possible outcomes, which is 6. This method or this idea is what we call the fundamental principle of counting, wherein if one thing can occur in m ways, and a second thing can occur in n ways, and a third thing can occur in p ways, and so on, then the sequence of things can occur in m times n times p ways. That means, going back to what we have solved a while ago, 3 here is the number of ways we could choose from a sandwich, that is m ways or 3 ways, multiplied to the number of ways we could choose from our beverages, which is an iced tea and pineapple. So if we multiply this one, because that is the operation that is being used in principle of counting, we will be able to get the total possible outcomes, which is 6. That means instead of doing listing method and a tree diagram, we will apply the fundamental principle of counting in identifying the total possible outcomes in each problem. Here's another problem. A coin is tossed 3 times. How many outcomes are possible? Take note that in this problem, we have a coin which has 2 faces. It could be head or tail. And remember that you're going to toss it 3 times. So the first time you toss the coin, we could have 2 possible outcomes. It could be head or tail. And then the second time you're going to toss a coin, it could be head or tail again. And then for the third time in tossing a coin, there are 2 ways. It could be head or tail. Now for us to get the total number of possible outcomes we have in this problem, we just have to multiply all of these numbers. Doing so, we have 2 times 2 times 2. You can express it in exponential form, which is 2 cubed. That means we multiply 2 3 times. If you have 2 cubed, or simply multiply 2 3 times, that is equal to 8. That means we have 8 possible outcomes in tossing a coin 3 times. The reason why we have multiplied 2 3 times here, because this is the number of times that we tossed a coin. So that's why we have multiplied 2 3 times. So if we do it in a tree diagram, here are the possible outcomes. Now let us discuss the last example. A die is rolled 4 times. How many outcomes are possible? Remember that a die has 6 faces, and every time you roll it, there are 6 possible outcomes. So the first time you roll it, we have 6 because there are 6 faces. Then 6 again for the second time that you roll it because there are 6 faces. And then for the third time, multiply it by 6 and do it the same with the fourth time you roll it. There are 6 possible outcomes. Now to get the total number of outcomes in rolling a die 4 times, you can express it in exponential form. That could be 6 raised to 4, or if you simplify that one further, you could have 1,296 possible outcomes. Therefore, there are 1,296 possible outcomes in rolling a die 4 times. That's all for today. Thank you for watching. I hope you learned something. If you haven't subscribed yet to this channel, please don't forget to subscribe and hit the bell button to update you on my next video.